Hey gang, today we're looking at solving one and two-step equations, a skill that you should have mastered as a seventh grader, but we want to make sure that you really got it down before we jump into some more challenging equations in eighth grade. So remember when you're solving one and two-step equations, it's kind of like you're balancing a scale, right? Whatever you do to one side of the scale, you have to do to the other to make sure the sides are equivalent, okay? So if you have multiplication in an equation, the opposite of multiplication would be to divide, and you would have to divide both sides of the equal sign to keep it the same. If you have addition, the opposite of addition would be subtraction. So you would have to subtract from both sides of the equal sign to keep them the same. If you had subtraction, you would do addition to keep both sides the same. If you had a fraction, you would multiply by the reciprocal to keep both sides the same. So the goal again is to balance the equation. Keeping both sides equivalent will lead you to the correct solution. So let's take a look at some examples. First, actually, some properties. So we have an equation is a mathematical sentence that contains a variable. One-step equations are easily solved mentally by using inverse operations. Those are the operations I was just talking about. When we use inverses, we are also using mathematical properties. Some of those properties include the addition property of equality, which is when we add a number to both sides of an equation. Something like x minus 8 equals 12. We would have to add 8 to both sides to find a solution, balancing the equation and getting a solution of x equals 20. Here I use the addition property of equality because I added to both sides to keep the equation equivalent on both sides. The next would be the subtraction property of equality. That's used when we subtract a number from both sides of an equation. So if my equation instead was x plus 8 equals 12, to balance the equation, I need to subtract 8 from both sides of the equal sign, resulting in x equals 4 as the solution. And here, because I subtracted to balance the equation to keep both sides equivalent, I'm using the subtraction property of equality. And then one more is the multiplicative property of equality. And that's when we multiply each side of the equation by the reciprocal of a number to isolate the variable. Okay, so similarly, say we have something like 2x equals 18. To solve this equation, I would divide by 2. That's what you guys are used to. You can divide by 2, but dividing by 2 is the same as multiplying by 1/2, which is the reciprocal of 2. So x equals 9. So we're going to be taking a look at all these properties and solving some very basic one-step equations to start. Here's our first example. So we have number one is 5x equals 30. We want to balance the equation by dividing both sides by 5, since 5 times x or 5x implies that multiplication is going on. So now you divide by 5 here, also divide by 5 here, and x equals 6, which makes sense. You guys could do this probably mentally. You know 5 times 6 equals 30. So when you're trying to find x in this case, it has to be 6. All right, next one. Here we have a over 15 equals 4. So here a is being divided by 15 to get 4. So we need to figure out, well, what number do I divide by 15 to get 4? In order to do that, we're going to multiply both sides by 15. And here we're still using that multiplication inverse property because a over 15 is like saying 1 over 15, and the reciprocal of 1 over 15 is 15 over 1. So you're multiplying by 15. And a equals, just a quick way to do this, 4 times 5 is 20. Bring down the 0, carry the 2. 4 times 1 is 4, plus 2 is 6. So our final answer is 60. So 60 divided by 15 results in 4, just like 4 times 15 is 60. All right, let's take a look at another example. Number 3. Here we have a plus 8 equals 13. Since there's addition in the problem, the reverse or inverse would be to subtract 8. Using the subtraction property of equality, we get a equals 5. Very, very simple problem. Number 4, now we get a little bit more challenging. We have 72 divided by d equals 8. Hopefully, you can figure this out in your head without needing a calculator. You think about, well, what number do you divide 72 by to get 8? Okay? Hopefully, you know the answer already in your head. Let me show you the math though. If I want to get d by itself, I might start by multiplying both sides by d. And when I multiply both sides by d, now I've made the problem a lot simpler to solve. So now I've got 72 equals 8d. And instead of dividing 72 by d, I'm dividing by 8. And 72 divided by 8 results in d being 9. Because 72 divided by 9 is 8, 72 divided by 8 is 9, and 9 times 8 is 72. All right. Number 5, another simple problem, but just the way that it is written can make it a little tricky. So we have 18 minus z equals 12. So we want to get the z by itself. In a lot of these cases, kids tend to then add 18 to both sides because they see a minus sign. But the minus sign is attached to the z, not the 18. That 18 is actually positive. The opposite of positive 18 would be negative 18. So we're going to subtract 18 from both sides, which results in negative z equals negative 6. 18 minus 12 is 6, so 12 minus 18 is negative 6. Then I have a negative and a negative. This negative z is like negative 1z equals negative 6. So if I divide by negative 1, I get z equals positive 6, which makes sense. I think you all know that 18 minus 6 equals 12. That's just the math behind it to solve the equation. Okay, number 6. Now we have one that is a little bit more challenging, and again, something that I would like you to be able to do in your head without a calculator. So I'm going to show you a real quick trick for these. Here we have 3/4 of x equals 24. So in this case, you still want to multiply by the reciprocal. So the reciprocal of 3/4 is just the flip of the fraction. So instead of 3/4, we're going to multiply both sides by 4/3. 4 divided by 4 is 1, so it cancels out. 3 divided by 3 is also 1, so it cancels out. So it's kind of like having 1x. Then we do the same thing over here, 4/3. Now, the trick is to divide by the denominator and multiply by the numerator. So I think you guys can all do these in your head. Divide by the denominator, d, d, then multiply by the numerator. And if you can remember this, it will make multiplying by a fraction so much easier. So now we do 24 divided by 3, that's 8, and 8 times 4 is 32. Final answer is 32. Again, divide by the denominator, multiply by the numerator to get rid of the fraction on opposite sides of an equation. All right, let's see what we've got left here. All right, you're on your own for 7 through 12. You can pause the video here and try those ones on your own. Check in with me as you're working to make sure you've got them right, or you can keep on going and come back to them later. It's up to you. All right, so now we're moving on to some two-step equations. And again, you should have seen these last year, and hopefully you remember the process. Whenever we're solving an equation, you kind of work the order of operations backwards. So hopefully you remember order of operations are parentheses, exponents, multiplication and division, addition and subtraction. Now, multiplication and division go together, and addition and subtraction also go together. You can do those two out of order. So if you do subtraction first and then addition, no big deal. If you do division first and then multiplication, no big deal. But multiplication and division go together, addition and subtraction go together. So that's when you're just simplifying a problem, not an equation. When you're solving an equation, you use the order of operations backwards. Okay, so think of getting rid of the addition and subtraction first, then getting rid of the multiplication and division second. We're not going to worry about exponents and parentheses at these times. So when we're solving an equation, this is something you need to remember. All right, so let's take a look at this one. We have 5x minus 2 equals 13. So working the order of operations backwards, do I see subtraction or addition? I definitely do. I see subtraction. Opposite of subtraction is addition. So I'm going to add 2 to both sides. I get 5x equals 15. Now, addition and subtraction are gone. Do I see multiplication or division? Yes, I see multiplication. Opposite of multiplication is division. So I'm going to divide by 5, getting a result of x equals 3. Done. Now, I can mentally check that in my head. I know 5 times 3 is 15, and 15 minus 2 is 13, so I've done it correctly. Again, I did that just mentally. 5 times 3, replacing the 3 with the x, minus 2 is 15 minus 2, which is 13. So I did it correctly. I'm not asking that you show the work for that, but sometimes if time allows and you have extra time, it doesn't hurt to do that in your head to make sure you've got the correct answer. All right, let's take a look at the next one. So number 14. Now we have, go back, 4 equals 1/6 n plus 11. So notice now that the bulk of the equation is on the right-hand side instead of the left-hand side. That's okay. You should be familiar with seeing that and not letting that throw you off. So I'm going to rewrite it and go through the same process we did before. So again, using my order of operations backwards, first I look for addition or subtraction, and I see addition, that plus 11. So I'm going to get rid of that first. I'm going to get rid of plus 11 by subtracting it. That's the subtraction property of equality. I'm left with 1/6 n equals 4 minus 11. Now, obviously that's going to be a negative because 11 is bigger than 4. I can think of 11 minus 4 in my head instead. 11 minus 4 is 7, so this is going to be negative 7. Now I have 1/6 of n equals negative 7, or negative 7 equals 1/6 n. The reciprocal of 1/6 is 6 over 1, so I can just multiply by 6. Multiply by 6. So n equals negative 42. Done. So hopefully these are coming back to you from last year, all the way back to last June. You probably did some practice with these types of equations. And we're going to be spending a lot of time doing these equations throughout the year. It should become second nature. All right, let's take a look at another example. All right, number 15, again, turned around, some negatives we have to deal with. So we're going to start with using our order of operations backwards, looking for addition and subtraction. I see subtraction by 4. The opposite of that would be to add 4 to both sides using the addition property of equality. So I have 6a equals something. Now I have to keep in mind I have integers here that I have to work with. When I see different signs, I have a negative and a positive, I find the difference. When I see difference, I mean subtraction. So if I have negative 16 and positive 4, since negative 16 has the largest absolute value, my answer is going to be negative. Then I can just find the difference between 16 and 4. 16 minus 4 is 12. I get negative 12 as my answer. So negative 12 equals 6a. Now I see multiplication. To undo that, I divide, and a equals negative 2. Done. All right, let's continue. Okay, so 16 is going to be the last example I do with you. Here we have, again, a equation that's been twisted around a little bit, and you can still handle it. We want to start by getting rid of the constant first. Now, when I say constant, that's a number by itself that might be added or subtracted from or to a number with a variable. So starting to get rid of the constant, this constant is 1. Now it's positive 1, so to get rid of positive 1, I would subtract it from both sides, resulting in 2/3 of b equals negative 13 minus 1. Now in this case, I have two negatives, so I like to think of same sign, find the sum, keep the sign. So negative 13 and negative 1 results in negative 14. Now I have a fraction, and I'm multiplying. So the opposite here would be to multiply by the reciprocal. The reciprocal of 2/3 is 3/2. 2 over 2 cancels out, resulting in 1. 3 over 3 cancels out, resulting in 1. So I have just B. And then multiplying by 3 over 2 on the opposite side as well. Remember, you're going to divide by the denominator and multiply by the numerator. Negative 14 divided by 2 is negative 7. Negative 7 times 3 is negative 21. Final answer. All right, so I've done a whole lot of practice problems with you, all problems that you should already have seen last year. So now you're going to prove to me that you can do these on your own at your tables. Check in with me as you complete each one. Once you're done, you can do today's exit ticket. Once that's done, you can start tonight's homework.